Good afternoon, year six. I hope you're well. We're going to look today within our geography about how much rainfall there is in various places across the globe, so across the world. We're going to revisit initially some of the ways in which historically elements within the globe have been classified, and then we're going to look at some data and how we could, some information, and then we're going to try and unpick some data and do some research ourselves. Okay. So to begin with, how does temperature, we're going to think about temperature a little more next week. This week, we're thinking primarily about rainfall vary across the globe. If we remember from last week, Koppen was a German botanist and climatologist who looked at how places would grow. Unfortunately, the picture at the top in the middle has got covered by the map of his classifications, but it shows that he'd sent small planes up into the atmosphere to try and collect data, looking at how arid and how temperate different climates were and whether they'd support the growth of plants. So the red element is that equatorial line across the center of the Earth, which shows one of the hottest places. And we can see in green in the center to the north of this map where we are located, a more temperate zone. And we can see as we go to the extremities of the north and the south, those polar regions. Now, those climate zones then that we looked at last week, just see if you can recall which ones, what the names were. See if you can make a note down for each biome based on the descriptions and the examples in here. So pause the video whilst you try and do that, please. Okay, going through these one at a time, then we can see we've got the polar region, which we talked about at the extremities of the north and the south, very cold and dry. We've got the temperate areas, which have cold winters and mild summers, such as where we live. We've got the arid spaces, such as the desert and Australasia, where they're dry and hot all year round, very difficult for things to grow in those arid zones. We've got the tropical areas, such as Brazil with the Amazonian rainforest, which have lots of liquid as they're very wet, as well as warm and hot all year round. We have the Mediterranean zones, such as Spain, and then the mountainous zones in the biome of this mountain. So hopefully you remember those 6 areas in terms of the way that the world is split up to describe the climate in those regions. If we remember, climate is different to weather because weather can alter from one day to another. And we obviously had the snow last week, and we've seen elements of cold days this week that being colder one day than another. That doesn't mean our climate's changed. It means that the weather on a given day and a given time have altered. Now we've got a bit of reading to do here. I'll read it with you, and then you're going to use this information in a piece of data analysis. So precipitation is the technical term for rainfall, and the rates vary globally and all over time. Okay, so precipitation is the scientific term for rainfall, rain or snowfall. Rain doesn't fall in the same quantity in any place around the world. There's different reasons for different rainfall patterns. Now, desert areas, if we remember those areas that we've looked at earlier, quite close to the equator, they've got limited rainfall as they receive sinking dry air from high pressure systems. So it's the nature of the air which is going through them, which doesn't contain many liquid droplets. The places which are a long way away from the sea are called large continental interiors, and they tend to be dry because they're so far away from the sea and other moisture sources, and the clouds can lose their moisture before they reach the center of these large continents. So North America, the center of North America is an example of that. So the areas around central Canada and Central America, the center of the country of America, are examples of that. Okay. So the moisture sources are lost. The polar areas are dry because cold air cannot get as much moisture as warm air. So because it's so cold, the air doesn't contain as much liquid, and precipitation can't occur so often. Okay, so those polar areas. And areas near the equator receive a high rainfall amounts because of the solar heating. Okay, so it's this idea that the evaporation, which we've learned about in our previous learning at school, where water evaporates due to heat being placed upon it. Now, because there's so much heat in these areas, the evaporation comes up, the rising air cools with altitude and forms conventional rainfall. Okay, so there's different areas have different reasons. We will try and get some pictures for this, but they weren't available this week. No, areas which are called mid-latitude, so they're somewhere between the centre and the southerly or northerly peak of the globe. So these are places kind of in the middle, may experience convectional rainfall and polar subtropical air masses meet here too. So this is when moist air cools, it gets cooler and then suddenly rains. Okay, mid-latitudes. And then we finally got this idea of mountain ranges which are near water sources can receive high levels of rain because of uplift. Okay, basically because they're near the water source, near things like the sea, they can get a lot of rain. Okay. Now, future climate change could change things. We looked at with our work with Peru how future climate change could be about to change the habitat and the environment in which many of the animals live. But this is also something that may occur in the future for some of the other that may affect rainfall. For example, monsoons are essential to certain climates where there's sudden deluges of lots of rain in a very short space of time. And in countries within Asia, these are getting shorter at the moment due to the increase in heat within the world. We'll look more at, you're going to do a bit of research as your primary function this week, and we're going to talk about how we present that research. And then next week, we're going to look at some more of the elements of the causes, because I think we benefit from more visuals, but unfortunately, they've not been available to us this week. Okay, so we'll go over some of these aspects next week again. Okay, so the work that I'm going to ask you to do, you're first of all going to plot some data looking at the average annual rainfall for the whole of Brazil, so the whole country of Brazil. Now, you've been given a chart which has some rainfall data in the grey box at the top, and it has this grid. Now, what I'd like you to do with this grid is to try and plot the along the y-axis, which is covered with that orange rectangle. You're going to plot the data values that you think need to go up there. So you make sure that each point is plotted equally, the gap between each point. So each horizontal line marks either 1 or 2 millimeters. Now, I suggest you could probably do 1 millimeter for each horizontal line. And once you've done that, you'll be able to see where you can plot the data for January. Now, unfortunately, it's not in line with where the actual number 45 is. But if you see one column to the left, you can see there I've started to plot it now. What I've done there is marking each horizontal line as worth 2, but if you're going to be marking each horizontal line as a value of 1, the gap, then the bar would be greater in height. Okay, and that shows us, and then you can plot across for each month. I suggest you change the color from one month to another so that we can see the contrast, and then you could show me that data for Brazil. Okay, that's your first task. At the end of completing that, you've got some questions relating to the data, and I'd like you to answer those questions on that sheet as well. Your second task as a geographer is to use the same STEM chart grid and then to use some data, but also to find out some data. So the data I'm giving you is about Manaus in Brazil and London in the UK. And you can see month to month the variance in the rainfall. What I'd like you to do again is to plot on the left-hand side where that y-axis is the data values for each month. So this is about centimeters rather than millimeters. Once you've plotted those data values, you're then going to note that here on the x-axis, we're going to have each month spread over 3 columns. So January there is the first, second, and third column because we've got our data for Manaus, which we're going to plot in a second. We've got our data for London, which we're going to plot in a couple of seconds. And then we're also going to have a third data set, which you're going to need to apply and research yourselves. So here's the data for Manaus. You can see it's the blue one, we just highlighted. Then we've got the yellow one, the London data. And already I'm noticing the variance between those two, and I'm thinking, oh, I wonder what that tells me about Manaus. I wonder what area of Brazil it is if it has that much rain. And finally, guys, you're going to then start thinking about a third value. Now, it's got a question mark at the moment because I've invented that place. But what I'd like you to do is for each month, plot 3 locations so that you can identify after researching some rainfall data, the variance. Now, if you can do that and then underneath write what that shows you about those different places, that would be absolutely stellar. So you could tell me that the different rainfall in Manaus compared to London shows me it's this type of biome compared to that type of biome, and that would therefore facilitate what kind of animals to live there or what kind of vegetation to grow there. So I'd like you to have a think about how you can present that data, and once you presented that data, how you can use that data to explain something to me. I look forward to seeing those completed later on, Year 6. Thank you very much.